Okay, so next question is suppose you have 500 observations and your regress wage measured in rupees per hour on experience in the labor market, that is experience measured in years, and on experience in the labor market squared, that is you are essentially running a quadratic regression. So this is your model. You must understand by now how to read this model. So these are your standard errors. These are the coefficient values. So where the standard is estimated equation implies the returns to experience is strictly increasing. Now this is not true because in this case it is negative. So this option is not right. The returns to experience is strictly diminishing. That is what this negative sign in front of this coefficient of experience square, because you must understand that in this case this square term gives you rate of change of wage with respect to experience. So in this case return to experience is strictly diminishing. This might be a potential candidate. The returns to experience is constant. This is not true. Experience has no statistically significant effect on wage. You can in the earlier class I talked that T statistic can be easily calculated by looking at the model is by calculating coefficient divided by standard error of that coefficient. You calculate the standard error and a T statistic for both these variables. You'll find that this option is not right. So in this case the returns to experience is strictly diminishing is the correct answer. Okay, so question 7, it says a linear regression model y is equal to alpha plus beta x plus epsilon, that is residual, is estimated using OLS. It turns out that estimated beta equals 0. That is your beta hat, that, or if in this case they are just using beta, this comes out as 0. So आपको ये clear हो जाना चाहिए that beta coming out as 0 means x does not explain any variation in y. ठीक है? So your ESS automatically becomes 0 because it gets multiplied by this coefficient. So r square is 0, it's true. R square is 1, not right. R square will lie between 0 and 1. In this case, R square is undefined, which is also not true because your TSS is still there. So in this case, your R square is 0 is true option. Okay, let us move to the next question. It says that using ordinary least squares, a market analyst estimates the following demand function. So this is a double log regression function. That is also that in this case beta is, or beta gives you the elasticity of output with respect to prices, and this is a constant. So they are also called as constant elasticity function. So where x is output, p is the price. In another formulation, she estimates the above function after dividing all prices by 1000. So what the researcher does is in the next model, she divide all the logarithm prices by 1000. Comparing the two sets of estimates, she would find that alpha hat and beta hat will be same in both formulation. This need not be true. Alpha hat and beta hat will differ across both formulations. Again, you can verify this will not be true. Alpha hat will change, but hat will not true. This option in this case is the right option where it says that beta hat will change, however, alpha hat will not change. So in this case, D is your correct answer. Okay. So next question is, consider the least square regression of y on a single variable x, that is you are running this type of regression. Which of the following statements is true about such a regression? The coefficient of determination, in this case r square, and is nothing but your simple r square that we understand. That is, in case of multiple regression, your r square is, it tells you the overall fitness of or overall fit of the model. So coefficient of determination r square is always equal to squared correlation coefficient between y and x. Correlation coefficient between y and x is summation xy. I'm not writing the subscript divided by x. So this is always equal to this term. Coefficient of determination r square is equal to square only if there is no intercept. This is not true because this is expressed in deviation form. Coefficient of determination r square is equal to the square correlation coefficient between y and x only if there is an intercept. So in this case, this is the true answer. Okay, next question is consider the two regression models where one of the model is this and another model is this, where variables z1 and z2 are distinct from x1 and x2. Assume that is error from the first model and error from the second model. They both are normally distributed with mean 0 and a constant variance, and the models are estimated using ordinary least squares. If the true model is 1, so now here comes the question. If this is the true model means what? It will satisfy the assumptions of Gauss Markov, and they will be a blue estimator, right? Best linear unbiased. So best के लिए उनका variance कम होना चाहिए. So if the true model is 1, then which of the following is true? So expected beta 1 this is not true because it says that variance of v and variance of u will be equal. In that case, the question is wrong. Variance of v is greater than equal to variance of u. This is a right option. This again is wrong by contradiction because this is right. None of the above, this is not. So in this case, your true answer is variance of second model, or variance of the error term of the second model is greater than variance of the first model. Okay. A similar question on this line is, let beta be the OLS estimator of the slope coefficient in a regression of y on x1. Let beta slash, I guess, yeah, be the OLS estimator of the coefficient of x1 on a regression of y on x1 and x2. Which of the following is true? So in this case, you must understand that if you are saying that this variance covariance of beta contains a term sigma squared x transpose x inverse. So if the beta dash is the OLS estimator of the coefficient of x1 on a regression of y on x1 and x2. In that case, your variance of beta, slash should be less than variance of beta hat. So अगर आप चारों options को देखोगे तो this will be the true option, that is variance of beta hat is greater than variance of beta slash. Okay. Let's move ahead. So this is a question. So it says the recent studies suggest that the migration to Indian cities from rural regions can be explained by quality of life, QL, state income as a ratio of aggregate Indian income given by Y, the ratio of state employment to overall employment in India, that is given by E. So this is a model. Now it says that the figures in parentheses are standard. The T statistic for the null hypothesis that quality of life index does not impact migration. So अभी हमने देखा था that T statistic will be nothing but value of coefficient divided by standard error. So in this case, quality of life मेरा variable है. So 1.2 divided by 0.8 and it must come to 1.5. So in this case, this is the true answer. Okay, again a question on variance. So variance covariance matrix. So consider the following model: y is equal to beta naught plus beta 1 x1 plus beta 2 x2 plus epsilon. Estimated using OLS, which of the following will lead to higher variance beta 2 hat? So guys, till now if you have not subscribed, please subscribe to the video because all these things are covered in previous lectures. You can go and watch the lecture series which talks about mean and variance of these OLS estimators. So covariance variance matrix of beta, that is all those estimators, are given as sigma squared x transpose x inverse. Now if you express this term in deviation form, you're ultimately if I'm writing beta naught plus beta 1 plus beta 2 x2 x1, so in that case my variance of beta 1 will look like sigma squared because it's a sigma squared term upon summation in this case x1 square multiplied by 1 minus r12 ka whole square. Similarly, variance of beta 2 will contain this term summation x2 square, and this will be the correlation coefficient between, because ultimately when you have more than one variable in the regression, that is, it becomes a multiple regression. So in that case, your correlation coefficients are, or those regression coefficients are partial regression coefficients, and it is precisely, these partial correlations that we talk about. That's why they are called partial regression coefficients. So it says that consider the model estimated using OLS. Which of the following will lead to higher variances? राइट सो एक तो अगर ये हाई होगा क्योंकि न्यूमरेटर में है तो आपका वेरिएंस हाई होगा. अगर आपका ये सैंपल साइज स्मॉल होगा तो ये टर्म स्मॉल होगा, सो ये डिनोमिनेटर में तो आपका वेरिएंस बढ़ेगा. लेस वेरिएशन भी होगा इस टर्म में, तब भी ये टर्म स्मॉल होगा, इसलिए वेरिएशन बढ़ेगा. अगर ये कोरिलेशन कोएफिशिएंट अगर ज्यादा होगा, so in that case this is 1 minus that term, so this overall term will decrease, so in that case your variance will increase. So in this case, if you go back to the question, you see smaller sample size, it will obviously lead to higher variances. Less variation in x2, again more variation in e, and this e is for the sigma square. Again, since we do not know sigma square, we try to estimate it in through the formula RSS divided by n minus k. Then higher correlation between x1 and x2. In this case, all the four options are correct. So correct answer is 1. Okay. So next question contains 3 parts. So we'll try to understand this model properly, because the next 3 questions are based on this model. So again, guys, we have covered or we have tried to solve all those questions that or the concepts of which we have already covered in our lecture series. So this is just an application of all those questions that we have learned in our class. So it is absolutely necessary for us to apply all those things that we have in theory, and these questions are typically asked in many of the interview questions of data and analytics firms as well. Okay, so next question is it says that the data from a random sample of 107 home sales in 2003 yielded the regression, and this is the model. P hat is equal to 119.2 plus you have this term BD, BA, HS, PS, A, PC, and all these variables description are given here. That is, your BD stands for bedroom, PA stands for bathroom, number of bars, HS stands for house size, PS stands for plot size, and in सबका units of measurement दिया हुआ है. Plot size measured in square feet, B is units, price is measured in rupees 1000. Okay, and then you have a dummy variable, that's poor condition. अगर आपका house poor condition में, then you assign a dummy variable 1. If house is, if the situation otherwise, then you assign a dummy variable 0. SER is your standard error of the regression, and you must understand this is nothing but sigma square upon n minus 2, or sigma square gets approximated by this RSS. So if question says that if a home owner adds a new bathroom to her house, which increases the house size by 100 square feet, what is the expected increase in the value of house? So मेरा यहाँ पे change क्या हो रहा है? Number of bath and house size. So number of bath increases by 1 unit. So 23.4 times that change in x, that is 1, plus 0.156 is the coefficient, and this gets multiplied by 100 because there's an increase in 100 square feet. So in total this comes out at 23.4 plus 15.6. This will be roughly around 39. So there is an increase of 39,000 in the value of the house. In this case, correct answer is 39,000. Okay, next question says that are the coefficients of BA and PC individually statistically significant? Guys, I leave this to you and just to give a clue. From how do you calculate the t statistic? Again, look the variables जिनके लिए हमें find करना है, whether they are significant or not. Coefficient divided by standard error of that variable will give you t statistic, and a general rule of thumb is that higher or closer the t statistic value to 3, that is if it is lying closer to the value 3 or greater than 3, greater is the chance of rejecting null hypothesis, राइट. सो जितना ज्यादा टी का वैल्यू 3 के करीब होगा उतना ज्यादा चांस है दैट यू रिजेक्ट योर नल हाइपोथेसिस. सो इन दिस केस रिजेक्शन ऑफ नल हाइपोथेसिस implies that your variables are statistically significant. So I leave it to you to find it out. Then next question says that if a home owner converts a bedroom into a bathroom, what is the expected increase in the value of house? Again, it's a very easy question, guys. सो इसमें क्या है कि आपका एक बाथरूम कम हो जाएगा, सॉरी एक बेडरूम कम हो जाएगा और एक बाथरूम बढ़ जाएगा. सो इस केस में आपका एक्सपेक्टेड इंक्रीज क्या होना चाहिए? द कोएफिशिएंट ऑफ बाथरूम इज 23.4, दिस इज इंक्रीजिंग माइनस 0.485, एंड यू विल फाइंड दैट this will be roughly equal to this 22.95. So this will be your true answer. Okay, so this was all about applying all those things that we have already covered in the class. In the next video, we are starting with violations of assumptions. So yes, guys, looking forward to that. Those discussions on heteroscedasticity. So if you like the video, please subscribe it and share it with your friends. Thank you.